Welcome back, everyone. For today's opportunity, I would like to, just introduce you to a game. So this game is not a usual game. It stimulates or you know make you um, experience some relativity effects. The game is made were made by MIT, and the game called A Slower Speed of Light. So this is the credit. This is the copyright. So made by team from Massachusetts Institute of Technology, America. Yeah. So let's see the options. Oh, we can change the colors here, the saturation of the colors, the volume, and look sensitivity. Yeah, so let's just play. Once upon a time, in a quiet village, there was a little child. Sadly, the little child fell into death's icy grip far too soon. The little child's spirit began the journey to become one with light. But the speed of light was too fast for the small and clumsy little spirit. Luckily, the spirit world is full of magical orbs that slow down light. Collect orbs to slow down light to walking speed so you can finally move on. See how many orbs you've collected, compare your own speed to the speed of light. Okay, as light gets slower, you will start to see beyond what humans can typically see. Okay. So in the real life, we can only see this range of light, the spectrum of light, only the visible light. We cannot see the infrared, and we cannot see ultraviolet. And in this game, it will allow you to experience what human cannot see. Okay, we can use WADS to move, mouse to look, and escape for options. Okay, let's go. So I found this game like I don't know, maybe a year ago. Yeah, I found this game like a year ago when I tried to. My lecturer gave us. It's actually a team work, a group project like that. Also, we have to collect orbs, and if we look at the bottom tab, it looks like if we collect the orbs, we are getting closer to the speed of light. As you can see in the right corner, like we're like the spirit symbol is getting up and up. And also there are some significant changing in color. Look, it's greener now. Yeah. Okay. Oh yeah, there is some color changing here. So as far as I know, the relativity, the special relativity theory was based on two postulates. The first postulate is the speed of light must be constant, and there were no absolute frame of reference. So okay. Oh, it's getting red actually. Can I get more purple? Oh yeah. That's we cannot see that in real life, right? We cannot see purple light. Yeah. This game is quite interesting actually. I like it. Okay, so let's just accomplish the mission. So we need to collect the 100 orbs. We need to collect 100 orbs, and let's see what is going to happen. So during collecting the orbs, we can see there are colors changing. Yeah. Oh, okay. It's quite disturbing actually. Okay, and we can see there are like yeah, like spectrum of colors here. We can see all the spectrum, which is not very common. Yeah. Well, it's not common also. It's like beyond common, and it's impossible to do in real life. But this game allow us to, yeah, to some sort of like experience the occurrence. We have 20 more orbs to collect, and this is a game that, from my perspective, because I have several projects regarding creating game. This game is quite, I think it's quite complex, you know. You cannot, it's just complex because you not you have to concern about the colors and the speed of light and these effects. Like there's so many colors, so many lighting, which from what I know, lighting is the most hardest thing to settings inside a game. Like, yeah, it's quite oh wow, oh, you see that black? That's an X-ray. I suppose that's an X-ray though. Look, wow, yeah, in the right side, look, wow, that's from what I know, that was a really short wavelength light. Really short wavelength light will not appear in colors, but it's black. Such as that wavelength, such as X-ray, gamma rays, like that. Okay, so we need 2 more. I cannot find it. Where are the rest of the orbs? We need 2 more, and I don't know what will happen after that. Okay, I saw that. So there are like some ghosts hanging around there. I think the spirits, they are looking for orbs also. So we cannot go back. Oh, if we stay, like, you're not moving, it will show the normal, yeah, the normal view, like the typically environment we see in real life. As we getting closer and closer to the speed of light, we some sort of cannot see the usual thing. This is really beyond what human can see. There is no technology right now in today's world. Oh, that's the last orb that can, you know, that can allow us, that can make you experience this. Okay, so okay, we found it. 6 minutes 54. Oh. Oh, wow, wow, wow. Okay, okay. That's a length contraction. That's a length contraction actually. If you know the effects of relativity, special relativity is not. Yeah, yeah. I think it's the effect of special relativity. The effects of special relativity is length contraction and time dilation, right? But it's actually uh, the basis of special relativity is. Oh no, I'm stuck. I'm stuck. No, no. Oh no, mommy. Yeah. Okay. Oh no. Yeah, but we see it. We saw it. Like, yeah. There's length contraction. Yeah, that's actually quite neat view or neat simulation of length contraction. Nice. Okay. So there's a question here. What happened? Okay. So let's click that. We have a quote here about Albert Einstein: make everything as simple as possible, but not simpler. In a slower speed of light, the speed of light slows down with every orb you pick up. It is impossible for you to reach the speed of light, but certain relativistic effects become more visible as you get very close. Okay, this one. So the effect is called relativistic Doppler effect. Yeah, we can see the infrared and we can see purple things. Yeah, light behaves like a wave, and different wavelengths appear as different colors. As you and other objects move around, the wavelength of light changes, appearing redder or bluer to your eyes. Some lights become infrared or ultraviolet, which your eyes cannot usually see, and other invisible sources of light will become visible. Wow, that's quite a complex game actually. You 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 have you need to have like big teams, big calculations, yeah, complex calculations to make the effect, and other complex thing, other hard things. And we can see here there's some drawing here. I see heat. Yeah, wow. Have you ever saw or seen a heat or heat? Come on. Searchlight effect. Yeah, we've done this also. When we try it, you can see like there's black thing, like we can only see black in the right side. I did it earlier, and I hope you saw it. Moving left, the objects on the left are brighter than the objects on the right. Yes, we can see that there were black in the right side and it was bright red in the left hand side. Okay, so light also behaves like a stream of particles called photons. When you run towards a stream of photons, more photons hit you and the object becomes brighter. This effect is also known as relativistic aberrations. Okay. Oh guys, it's too bright. Okay, so when we move to the left, the photon were, the first part that will receive photons is the left part, and there were no photons left for the right side. That's why it's darker, I think. Yeah. Now this one is special relativity. Like I mentioned, it looks like length contraction for me. Light always moves at the same speed. So if the speed of light is constant, then the distance and time in the world around you have to warp. Yeah. Your time is different from the time in the world. Time dilation. And your distance are different from the distance in the world. Lorentz transformation, or length contraction, I think. You have to be much closer to the speed of light to notice the more dramatic effects of Lorentz transformation compared to the Doppler and searchlight effects. At the end of the game, the Doppler and searchlight effects are removed to make the Lorentz transformation easier for you to see. So it's actually, you know, like the sum of every effect. So it's not really missing. The effect is not missing actually, because when we get to the last orbs, we cannot see the colors anymore. There were no light effects anymore when we reach that, but the effect that is appear is the Lorentz transformation or the length contractions. But in the reality, when we reaching the speed of light, then we will experience these three effects. But how can time and space stretch? It seems so unreal. So the spirit said that, and Einstein just answered science. Interesting. This game is interesting. Runtime effect. How beautiful, I wonder if they are dead. Normally, light is extremely fast, but it still takes time for photons to reach our eyes. When you look at anything, you are actually observing incoming light from some time in the past. The farther you look into space, the further you look into history. This is easily noticeable when you look at objects moving relative to yourself. Objects normally beyond your field of view can become visible when you move near the speed of light, as you see them as they were in the past. Lincoln's been shot. Photon, for something so bright, you sure are slow. Wow, just like the stars actually. What we see like tonight or tomorrow is actually like 100 years ago. Yeah. Well, that's it, I think. Yeah, thank you for all of this, guys. And of course, Albert Einstein. I think this is the paper of photoelectric effect. Yeah, this is the paper of Albert Einstein talking about photoelectric effect. Thank you, MIT. Well, I think that's it, guys. If you want to play this game, you can easily find it online. Just type the title and you will have the game. So this is a game that makes you learn something new, and you can use this maybe to demonstrate some relativity effects to students or friends or anyone who are interested in relativity, yeah, or who are interested in science. Thank you. Goodbye and see you on the next project.